Hello, guys. Welcome to the Introduction to Forensics workshop. I'm Armando, the president of the Cyber Club, and I'm happy to do this. So, get into it. So, it's a little preview of the workshop. What is forensics and what happens during that process? We're going to go into a little computer networking since we're going to be looking at a packet capture file, and just requires a little fundamentals, not too much. And then we're going to interact with the packet capture file and a virtual hard drive to recover some files, and then sum everything up. So first off, what is forensics? Just doing a quick Google search. It's basically using evidence that can be used in the court of law when people have done something bad. Like if there's a hacker, they got caught, they're trying to delete stuff, or maybe they have a bunch of files that are encrypted and we're trying to recover them and use it as evidence. Some things that should be done is working in a controlled environment. I'm going to be using my own computer only because we're going to be using challenges from a CTF. But after looking online, I've noticed they usually do it like on a virtual machine so that the files won't get damaged. And whenever you're working on files from another computer, you don't really want to use that computer because you're giving more possibility of some data being messed up, or you just never know. So typically they'll take a copy of the hard drive of that computer and work on it somewhere else and leave that computer alone to not tamper with the evidence at all. And then once you find the evidence, you present it, obviously. So we have a packet capture file that we're going to look into. And before we get into that, I just want to go into a little bit of computer networking so that when we look at the packet capture file, we could understand it a little bit more. So here are some funny pictures. I just put a comparison between TCP and UDP, which are two of the most common protocols that are used in computer networking. TCP is basically, you can see here, there's like a picture of mom and dad. They like are agreeing on handing each other the baby. But in UDP, it's just like giving it. So essentially in TCP, the transfer of information is agreed upon between two computers or two people that are interacting. In UDP, it's just keeps getting sent and there's no check for data loss. That's more common in video streaming since there's like numerous amounts of people that are trying to see the same thing. And that may be why you see it buffer sometimes if you're ever streaming something. So this one here, the sending positive vibes your way, that's more UDP. It just doesn't even care. It's just sending it out. And this handshake is what we're going to see in the next slide, which TCP uses, which is called the three-way handshake. So here's essentially what the three-way handshake does in the form of packets. So in analyzing network traffic, we see a lot of packets. And what I like to say to people is packets is to the internet as cells are to biology. So cells are like the fundamental building blocks in biology, and in the internet, that's packets. So when a three-way handshake is going to get initiated, first the computer sends a synchronization packet to the computer that it's going to communicate with. That computer responds with a SYN ACK packet, ACK meaning acknowledge, and it's saying, yeah, I'm here, are you here? And it's like, yeah, I'm ready. So then the final computer agrees it's ready, and then the transfer of information starts happening. So we just need that fundamental knowledge to really look at the packet capture file. We can go into it a lot more, but I think this is enough. And then before we start analyzing, I'd like to thank Urmia University and Urmia University of Technology for allowing us to use the challenges. I had asked them beforehand, because I had done them in a CTF they were hosting, and I liked them because they were very simple and not too complex to follow along. For people who haven't done challenges with the packet capture before. So if you just go into the files where I shared the files with you guys on Discord. If you have Wireshark installed, you can just double click on the packet capture file. It should open. So someone was on a network, and our goal is to find the flag. That's what this challenge was. So the story for this packet capture file was we had to look for the domain Mr. Gray and decrypt their traffic. So the first thing I do whenever I open a packet capture file is I look at how many packets there is. As you can see, there's 168. There's way too much to look through. I'm not gonna click on every single packet because, as you can see here, there's even more information about each packet. There's just too much to look for. So in order to minimize how much I'm gonna look for, I'll go here into my statistics and go into protocol hierarchy, and it'll basically give you a really big overview of what everything is. So if you're looking for something specific, like if you're looking for something that was transferred in TCP, you can right click on transmission control protocol and then apply as filter and selected. And now you have less to look at. As you can see here, it has 131. It's obviously not that much little, but in some instances, it'll shrink down to like 5 or 6 packets when you're looking for something very specific. So that's something that I like to do when I'm looking at it. I like to look at the big overview because there's just too much to look at. You can't go into every single packet to analyze it. So another thing here is, since we were just looking at the fundamentals of networking, we can actually see the three-way handshake happen in this packet capture file. As you can see here, there's a source IP address 192.168.183.222 and destination 10.10.34.35. And the info for that packet is that it's sending a synchronization packet. The packet immediately after that, the source and destination addresses are flipped. So we can see that the computer that received that initial synchronization packet is now sending back another packet, which is the SYNAC. So it's responding to the initial communication. And the final computer responds. The initial computer that started the communication responds with the ACK packet saying it's ready. And now we have the client hello. So that's the information is now being processed through TLS, which is a transport layer security, which is what we're going to look at today to decrypt some of the traffic. So before we go into decrypting the traffic, one thing I wanted to cover was that this tool can capture network traffic wherever you're at. So when I first learned about that, I was thinking, what's stopping someone like from using this, going into Starbucks and just turning this on? Because this tool can capture network traffic. This button right here, start capturing packets. I didn't run this application as administrator, but if I did, I could just start capturing network packets of people that are on my internet. And so you would think that they'd be able to see everything that you're doing. However, there's a thing called encryption keys that actually encrypt everything in your browser for you. So they can see what you're doing. Like, for instance, let's look at this. Right click on the packet, go to follow TCP stream, and we could see that this is encrypted. We don't understand any of this. So if there was like an adversary looking at your network traffic, assuming they don't have your keys, they won't be able to see it. So that's assuming that you have encryption or certificate authority that's on your browser that's encrypting everything for you. You can see here, Let's Encrypt. That's a free platform online that gives you a certificate authority in order to encrypt your data on your browser. So for this challenge, we were actually given the decryption keys. And that's what I wanted to showcase, that with the decryption keys, we can look at all the encrypted data in plain text format. So in order to do that, just go to Edit and Preferences. So increase this a little bit. Protocols, type T, look for TLS for Transport Layer Security. TLS, and then master key secret log file name. Here I already have it. It's in the forensics workshop file that I shared with everyone, and it's this masterkeys.log. So you click on that and then hit OK. And nothing's changed in the view of Wireshark so far, but so yeah, I'm gonna just use some of the syntax from Wireshark. The TLS.handshake.type equals 1. So we're gonna look for all the TLS handshakes that happened in this file and decrypt it. Well, we already decrypted it using the keys. And here we have like a hex dump of everything. And for this particular challenge, we had to look for Mr. Gray, the domain Mr. Gray. And you can see it right here on this portion of the packet. So we can go to File, TLS stream, and now we see everything decrypted and easy to read. So this is basically all the GET requests, the response from the server. Here we see giving us CTF and the flag that we were supposed to find. So this was a good little challenge just to show some decryption and how it works when you're analyzing packet capture files. I actually didn't know how to do it before I did this challenge, so it was a good intro into learning more about how it works in the real world, because most of our traffic is encrypted. So decrypting it using some keys was pretty fun. And next thing we're going to work on is the virtual hard drive. Especially with the virtual hard drive, you'll want to be in a controlled environment. I know this is safe because I've already worked with it. It's fine. But something you could do is that you can actually work with this virtual hard drive as if it's one of your drives over here, like your C drive or Google Drive. In order to do that, you could just go into right click on your Windows thing, go to Disk Management, give it a second to load. And then click on your current drive. Mine is a C drive. And then I'll go to Action and attach virtual hard drive. You can look for the virtual hard drive. I'm already in the folder, so it's right there. Click OK. Now, when we go back, we're in the hard drive. So I tried, initially I thought this was going to give me the flag, but it wasn't. It's not going to do anything for me. Oh, yeah, it shows you this, but it doesn't really give you what you need. So this is just a little example of what you could do with the virtual hard drive. But really what we're going to do here is some file recovery. So if there was like an adversary that left their computer there, then we would get into their hard drive, get a virtual hard drive of their actual computer, and look into it in a controlled environment. So here I'm going to be using Autopsy. It's okay if no one installed it. It's a pretty resourceful, as in it uses a lot of resources on a computer. It's like a 1 GB program, so it uses a lot of power to run. And we're going to open this in order to recover some files from that hard drive. And this is a pretty serious application. I think even law enforcement uses it. I was watching some videos online, and I saw a full series for people that work in forensics for like police departments and stuff like that. So this is a real world application. So in order to look at the virtual hard drive that we just got, this number, all this stuff. I'll give it a second. Okay. Next, and select source type, this image or VM file. We'll look for it. So let's browse. Browsing through my whole files. This workshop. There it is. Open. So now you can see what was actually in the hard drive and what we can recover. So here we have 2 archives. So we have some zip files. You see the zip, the look behind, that was not available before. But now looking at it more deeply, analyzing the actual hard drive, we can extract it. So this is some encryption. Oh, it's password protected. This is probably what this password is for. So right-clicking on that, we can extract the files. And let's put it back in the forensics workshop. Zip. Okay. So now we can go back into our actual Explorer and see that the zip is right here. But trying to extract it doesn't really doesn't work. So I had to use 7-zip in order to actually extract it. Open archive. Extract. And then we're asked to present a password. And that was the password that was here. This. And then we see we have our flow. There you go. So that's just a little challenge on analyzing virtual hard drive. Something really cool here is that we can see some deleted files. Like let's say someone was at your doorstep and you like wrote a script to delete all your files in case something happens. They could still recover it because the way memory works is that when you delete a file, you're only giving the memory you're giving up that memory to be overwritten. Until it's been overwritten, you can't really, the memory is still there because it's just available to be overwritten. It hasn't been overwritten yet, at least to my knowledge. I'm pretty sure that's correct though. So yeah, there's a little file called HackerScripts, and I made this file in the hard drive just to prove. Right here it says Armando made this file to prove that just because you delete something doesn't mean it's gone forever. So yeah, just because you delete something doesn't mean it's gone forever. Maybe with some time, but in that very moment, it's probably still going to be there. So yeah, that was a little introduction on forensics. If anyone has any questions, I'd be more than happy to answer them. No questions?
So what is like men used for? Is it people who like delete their files for like having things that are not supposed to be on your computer?
Yeah, I mean, it's forensics. It's like I was looking at some pictures of autopsy. How do I remove this? This is so.
And we feel like law enforcement uses it, right?
Yeah. So yeah, looking at some of the pictures, it's just shouting forensics, like a lot of data recovery. Yeah, probably people had things they weren't supposed to, or they did something illegal. Yeah, I don't want to list anything specific, but you know what I mean. Mostly like evidence on the computer that they're trying to use.
I feel like the first thing, shark thing,
Wireshark, yeah.
and Wireshark.
Mm-hmm.
What you did was you basically like used TLS to decode the message, right?
Yeah, I had some keys, and the keys were given, and I just decoded it and looked for the domain that I had to look for. Because usually when you're given like quote unquote evidence, there's like a little story to it. So like search for this or search for this domain, you know. So that's what I did. I put in the keys.
Which that was like capture the flag, right?
Yeah, that was a
I
little
think
chat.
that's what cybersecurity, Cyber Patriot was.
Oh, okay.
And
Yeah, that's cool. Yeah. Yeah, so mostly that's sort of what it's about. A lot of other things too is like images, like actual
images,
pictures. I guess I could show you one. I was working on, I actually worked on this today. It was like a write-up for something.